Hello, everybody. I'm Gabriel Lubbock, and this is my project on exploring how we interact with social media using eye tracking as a tool. So just to start off, why am I so curious about social media? Why did I want to go into this? Well, social media for me is a really personal thing, and the way we interact with it for me personally just wasn't very healthy. I was spending way too much time on my phone. I was stressed out, and it was impacting my relationships. My girlfriend was getting mad at me more, and it didn't feel like I had a healthy relationship with particularly my phone and particularly with Instagram. And I got much more interested in this when I read a New York Times article about how it was possible to take back some of the control of our phone by moving our phones from color to grayscale. And that really got me thinking about how small design changes, like the colors that someone put in an app or on your phone home screen, keep people coming back even when they think about it in a broader sense. Maybe that's something they wouldn't want to do. And so I wanted to really explore how these design choices could make me feel back in control of my time, how I could think about design as a way to put people in control of their phones. And I wanted to study how people interact with their phones by using eye tracking. Eye tracking is a tool that uses a series of cameras to figure out where someone is looking in an experiment at any time. This picture right here is the tool we used for our experimentation. It's the iLink 2 camera. It has a series of cameras looking at your eyes and a series of cameras off the head to figure out which direction your face is pointing at any given time. It focuses on your eyes and figures out whether you're doing a saccade, which is a quick sort of movement with your eyes, or a fixation, where your eyes are set in a single place. Those are represented here with some of the data that I collected, where the blue lines are quick saccades and the red lines are fixations in a single place. They're moving right now, but I'll explain why that happens a little later. So in order to, this eye tracking allows us to figure out what sort of attention people are paying to any sort of media, not just social media. People scan through a piece of media differently depending on how they're interacting it, what they're trying to gain from it, how long they're spending with it. So people might spend a lot of time with some text or move quickly from picture to picture if they're not really paying a lot of attention. So I started out by just looking at how other studies had looked into different mediums of media. So these studies were primarily about newspapers, which is what the earliest eye tracking studies were about, and websites. The newspaper studies were often to figure out what was the best way to lay something out and where you could position advertisements in order to make sure people were going to look at them. Website studies found something called an F-shaped pattern, where you scan down the left side of a page normally and go to the right when something catches your eye. This is two different ways to show eye tracking data. On the top, we see a heat map where the areas where people look at a lot are colored in red, and this has nothing to do with the path someone takes through the website, just has to do with what sorts of features caught their eye the most and they come the most back to. On the bottom, we're looking at an actual eye path. This shows where someone's eyes went through at a given time. We can see that quickly glancing at the pictures and spending a lot of time reading some of the articles. This is what my data will look more like when I show it to you later. However, as I continued my research, I found that a study of social media, and particularly a study on mobile phones, was a lot less robust. I could find a lot less data on it. And this surprised me because the main way I interacted and the thing I was most interested in to begin with was Instagram on my phone. I found nothing that established a general eye tracking pattern, a natural eye tracking pattern for Instagram. And I found very little studies that looked at people using a mobile phone. And one of the possible reasons for this might be something we hit up with very early on. We realized that the phone itself doesn't take up a large enough percentage of your field of view to get really precise eye tracking data. And for that reason, we created something that looked like an Instagram page and blew it up onto a projector so that we could look at how the mobile format affected how people scanned through the page naturally. And this is what we had. So our general project plan to begin was to just establish a general pattern of use with Instagram, figure out how people naturally scan through it, how much time they spend on photos, when they look at text, and then hopefully building on that, we could see if we could alter that by changing some variables like color or formatting. Regrettably, after we only tested 2 people, the in-person testing had to be cut off due to the coronavirus. In order to do this testing, we had to make adjustments to the iLink and the software around it. So what you're looking at here is a test. So when you're scrolling through an Instagram page, the image moves around you. And I don't care about where you're looking on the screen. I only care where in the image you're looking. However, up until this point, all the code that I could find written for the iLink tracker simply looked at the images on the screen as static. It didn't care where an image, how an image was scrolled up or down, just where you were looking at the screen. So I had to write some code to adjust based on how up or down a timeline was scrolled, where your eyes were focused on that picture. And you can see here, these two dots down here, I was saccading back and forth from them, moving from one to the other, even though they were on different parts of the screen while I was looking at them. And then these longer red lines you see are me holding my eyes steady and moving the image around it. So I have control over how the image moves up and down. And if I hold my eyes steady and move it up, my eye tracker passes down. So then we began running the experiment. We created this Instagram-like format, which we blew up onto this projector here and had people run through 6 timeline images, which I created by creating a blank Instagram account and looking at what Instagram thought a generic user would find the most captivating. We managed to run through 2 subjects through 6 different timelines before testing had to be cut off due to the coronavirus. We got a little bit of pilot data from this. Again, when you're looking at this, remember that this is me keeping my eyes steady and scanning down, and this is right to left movement with the saccade. The trials indicated that the program worked, but I wasn't yet at a point, and I'm not yet at a point where I feel like we can make larger generalizations about natural eye pathing tracks just based on these 2 subjects worth of data. That being said, I am proud of the methodology that we created and the code that we created. We established a code that can render those long timeline images in MATLAB, and this allows us to run a study of any sort of social media. Anything that is run in a scrolling fashion, I could just plug in those images into this and run something that looks a lot like that app. Additionally, we've repurposed the parsing of the data so that it can adjust it based on how far the image is scrolled at any given point. Right now, since the coronavirus happened, I've just been cleaning up the code and thoroughly commenting it so that if someone else in my lab or anyone else would like to use this same code to build on it, or if I want to build on it in the future, it'll be really easy to do. I just want to say thanks to Arash, my whole lab, and KHC, and wonder if you guys have any questions.